In today's session, we will discuss some of the most important and frequently asked questions on the BJT and associated circuits like biasing techniques, common emitter, common base configurations, and amplifier analysis. All these question models are based on the previous year examinations of GATE, IES, ISRO, DRDO, Polytechnic Lecturers, and other state public sector unit examinations. Let's welcome to the channel Electronics Pariksha. Let's see the question. Assuming that beta of the transistor is extremely large and VB is 0.7, the IC and VCE in the circuit shown figure are. So this is the circuit here. He's asking us to find out the Q point. Q point is nothing but VCE and IC, the collector current and collector emitter voltage. So let's apply the Kirchhoff voltage law at the input loop. If you apply the KVL here at the input loop, to find out the voltage at this point, you have to find out the voltage at this point, VB, the voltage across this 1 kilo ohm resistor. So by applying Kirchhoff voltage law, you can get that. So here VB can be given as the current that is flowing through the resistors of 4 kilo ohm and 1 kilo ohm. That is nothing but VCC divided by R1 plus R2 multiplied by R2. This is the current and this is the resistance. If you multiply this, if you substitute the values, 5 divided by 4 kilo ohm plus 1 kilo ohm multiplied by 1 kilo ohm. So the voltage will be 1 volt. This is the voltage. This is 1 volt across the 1 kilo ohm resistor. Now you apply the Kirchhoff voltage law in the input loop. That is the base emitter loop. By applying KVL, Kirchhoff voltage law, in the base emitter loop. This VB is equals to VB base emitter voltage plus the voltage across the emitter resistance VE, which can also be written as IE into RE, the emitter current multiplied by emitter resistor. Okay. So now substitute the values. You will get emitter current IE as VB minus VBE. VBE is 1 volt, VBE is, we know, base emitter voltage is 0.7 volts. The emitter resistance is 300 ohms. So now the emitter current is 1 milliamp. Here it is already given that beta is very large. Here beta is extremely large, he is telling. Extremely large. That indicates the collector current and emitter current are same. Beta is equals to IC by IB, collector current divided by base current. Beta is very large. In a sense, base current is very less. So this indicates the collector current and emitter current both are approximately same. So now the collector current can also be written as equal to emitter current, that is equals to 1 milliamp. Now we got the collector current. So now you apply the Kirchhoff voltage law in the output loop. This is the output loop. Now by applying KVL in the output loop, what you will get? You will get the equation VCC is equals to IC into RC plus VCE, collector to emitter voltage, plus VE, emitter voltage. So that is nothing but IE into RE. Now by substituting these values, you will get VCE is equals to, VCC is, the value of VCC is 5 volts here. So 5 volts minus the collector current is 1 milliamp. Collector resistance is 2.2 kilo ohms and emitter current is again 1 milliamp. Emitter resistance is 300 ohms. So by solving all this, you will get the VCE voltage as 2.5 volts approximately. So now the Q point that is VCE ICQ is
like the video, share the video and subscribe to the channel for better content and more videos.
Equals to 2.5 volts 1 milliamps. So now the answer is option C. This question is asked in GATE 2004. We'll see the next question. Assuming VC saturation is 0.2 volts, beta is 50. The minimum base current IB required to drive the transistor into saturation is. So he's asking for the minimum base current. He has already given beta is 50, VC saturation is 0.2 volts. So you just apply the Kirchhoff voltage law in the output loop by applying KVL in output loop, assuming that the transistor is in saturation. We'll get VCC is equals to IC into RC plus VC saturation. You will get collector current is equals to VCC minus VC saturation divided by RC. Substitute the values. VCC is 3 volts, VC saturation is 0.2 volts, collector current is 1 kilo ohm. So the collector current saturation, this is IC saturation. Because we have substituted VC saturation value, the resultant collector current is also saturation collector current, is equals to 2.8 milliamps. This is the saturation collector current. Now he's asking us to find out base current. You just find out base current is nothing but IC divided by beta. So now base saturation current is nothing but IC saturation current divided by beta. This is a 2.8 milliamps divided by 50. So this results in 56 microamperes. So now the answer is option A. We'll see the next question. In the silicon BJT circuit shown below, assume that the emitter area of Q1 is half of the Q2 transistor. Emitter area of Q1 is half of the Q2 transistor. So emitter area of Q1 is half of the emitter area of Q2 transistor. Now the value of I0 is, here we must understand when the emitter area, the total current depends on the emitter area. So when the emitter area of Q1 is half of the emitter area of Q2, it also results in the emitter current of Q1 is also half of the emitter current of Q2. Because depends on the emitter area, the current will generate. Similarly, the collector current of Q1 is half of the collector current of Q2. So if you can find out the collector current of Q1, you can easily find out the collector current of Q2 and vice versa. Okay. Now this ICQ2 is nothing but I0. ICQ1 is equals to half of I0. This ICQ2 itself is I0. So now I0 is 2 times that of ICQ1. So let's find out ICQ1 by applying the Kirchhoff voltage law in this input loop, by applying KVL to transistor Q1. You will get, here there is a voltage drop, this is the current I1, and there is a voltage drop VBE here, and this is a VEE. Okay, so now you write down the equation I1 into RC, that is collector current or normal resistance R, plus VBE plus VEE is equals to 0. This is the equation. Now you substitute the value, you need the value of ICQ, that is nothing but I1. I1 is equals to VEE minus VEE minus VBE divided by R. Substitute the values. VEE is minus 10 volts. So minus of minus, it is 10 volts plus 10 volts. VBE will be 0.7 volts. The resistance is 9.3 kilo ohms. So this results in 1 milliamps. So ICQ1 is equals to 1 milliamps. So what about ICQ2? Now I0 is equals to ICQ2, which is nothing but 2 times of ICQ1, that is 1 milliamp. So it will be 2 milliamps. So the answer is option B. A small signal source VIF is equals to A cos 20t plus B sin 10 to the power of 60 is applied to the transistor amplifier as shown below. The transistor has got beta is equals to 150. Input impedance HIE is equals to 3 kilo ohms. Which of the expression best approximates output voltage? So he's asking us to find out output voltage. The input voltage is given here. This is the expression for input voltage. So VIF is equals to A cos 20t plus B sin 10 to the power of 60 Okay. Now the output voltage is given by voltage gain multiplied by input voltage. Simple. So now what is the voltage gain? We shall find out what is the voltage gain. The voltage gain is nothing but output voltage divided by input voltage. The output voltage is nothing but the collector current is the output current multiplied by output impedance, the load impedance, divided by input current base current multiplied by input impedance, that is HIE. Now here the load resistance RL is nothing but the collector resistance. This is the collector resistance. Now he has written this IC by IB can be written as current gain because this is the output current by input current. So current gain AI multiplied by collector resistance RC divided by input impedance HI. Now you substitute the values, the voltage gain AV can be written as the current gain is given as 150, that is beta. Collector resistance is 3 kilo ohms. Input impedance is also 3 kilo ohms. So now the voltage gain is equals to, here we have to put minus because this is a CE configuration, common emitter configuration, in which the output and input differs by 180 degrees. So minus symbol is required. So now the voltage gain is minus 150. So the next step is to find out input voltage. Here, if you observe carefully, the input voltage contains two components, that is 20T and 10 to the power of 60. The frequency is different. So VIF is equals to A cos 20T plus B sine 10 to the power of 60. Here omega 1 is equals to 20 radians per second. Here omega 2 is equals to 10 to the power of 6 radians per second. So the frequency varies widely. If you see in the diagram, there is an input capacitor 100 nanofarads. This input capacitor should allow these frequencies. We have to find out whether it allows these frequencies or not. So let's find out the impedance, that is XC1. The impedance of the capacitor is omega C. Okay. So which is equals to, now 1 divided by this omega value is 20, capacitance value is 100 nanofarads. Now XC1, the impedance for the first frequency is nearly 5 into 10 to the power of 5 ohms. That is nothing but 500 kilo ohms, which is very, very high. Which is very, very high. So it is very clear that the input capacitor 100 nanofarads drops this frequency. It will not allow this frequency to go for amplification. Okay. Now similarly, we'll find out the impedance of the capacitor for this second frequency. XC2 is equals to omega 2C. So if you substitute the values, omega 2 is 10 to the power of 6 and this capacitance is 100 nanofarads. So this is equals to 10 ohms, which is very less. So this frequency will be passed to the output. So now the output voltage is nothing but voltage gain multiplied by input voltage. So the voltage gain is 150 minus 150. Input voltage is only B second term. The second frequency will be available at the output. So output voltage is minus 150 B sine 10 to the power of 60. So now the answer is option D. We'll see the next question.
Like the video, share the video, and subscribe to the channel for better content and more videos.
For the BJT circuit shown, assume that the beta of the transistor is very large. VB, base emitter voltage, is 0.7 volts. The mode of operation of the BJT is. He's asking for the mode of operation. First, we must be very clear if the IC value expected, the IC current IC value, collector current value is greater than IC saturation, or the IB value is greater than IB saturation, greater than or equal to, then the transistor is said to be operating in saturation mode. Otherwise, it will be in active region. Otherwise, it will be operating in active region. So let's find out the IC expected value first. IC expected value can be found by applying Kirchhoff voltage law in the input loop. By applying KVL at the input loop, you will get VBB is equals to base emitter voltage VBE plus emitter voltage, that is IE into RE. So substitute the values, you will get the collector current, sorry, the emitter current, which can also be equal to collector current, which can also be written as collector current, is nothing but VBB minus VBE divided by RE. So now that will be equal to 2 minus 0.7 divided by 1 kilo ohm is equals to 1.3 milliamps. This is the IC expected value we got. Now we shall find out IC saturation. How to find out IC saturation? You have to apply the Kirchhoff voltage law in the output loop by applying KVL in the output loop and consider VCE as VCE saturation. Okay, so VCC is equals to IC saturation RC plus VCE saturation plus IE is nothing but again IC saturation. Okay, the same current flows. So because he has given the beta is very large, whenever they give beta is very large, we have to assume that there is IB is very less. This is an assumption that IB is very less. So the emitter current is equals to approximately collector current. This is the assumption. So now you substitute the values. VCC value is 10 volts. The IC saturation is not known for us. RC, the collector current is 10 kilo ohms. The emitter, sorry, collector resistance is 10 kilo ohms. Emitter resistance is 1 kilo ohm. VC saturation is 0.2 volts. So by solving all these things, you will get the collector current, IC saturation as the collector saturation current, that is IC saturation as 0.891 milliamps. So it is proven that the IC expected value, that is 1.3 milliamps, is greater than IC saturation. So transistor is said to be running in saturation mode. Okay, we'll see the next question. The DC current gain beta of the BJT is 50. Assuming that emitter injection efficiency is 0.995, the base transportation factor is. So we have a formula here. Alpha, that is the DC current gain of common base, is equals to emitter injection efficiency multiplied by base transportation factor. Base transport factor. So alpha is nothing but emitter injection efficiency, that is gamma star dot beta star. This is not current gains of common emitter and common collector. This is the emitter injection efficiency. This is the base transportation factor. Okay, there is a difference. So now we have to find out the value of alpha, which is DC current gain of common base. So we know that alpha is also equal to beta divided by 1 plus beta. So beta is given as 50. So alpha is 50 divided by 51. Substitute these values. 50 divided by 51 is equals to, the emitter injection efficiency is given as 0.995. He is asking us to calculate base transport factor. So this results, the base transport factor will be approximately 0.9852. So the answer is option B. We'll see the next question. So in this question, it is given as I'll give you the complete question. Here it is given in the question, beta is equals to 50, VBE, base emitter voltage, is equals to 0.7 volts. He is asking us to find out the base current and the collector voltage. Collector voltage in the sense here, PC. At this point, what is the collector voltage or output voltage he is asking. Now let's see that in great detail. Here the emitter current. The emitter current is equals to collector current plus base current, which can also be written as 1 plus beta into IB. So by applying the Kirchhoff voltage law in the input loop, by applying KVL in the input loop, we will get BCC is equals to IB into RB plus VBE, base emitter voltage, plus emitter voltage, that is nothing but emitter current multiplied by emitter resistance. Here emitter current can be written as 1 plus beta into IB. 1 plus beta into IB and emitter resistance. Substitute the values. VCC is 20 volts. The base current is not known to us. The base resistance is 430 kilo ohms. Here 1 plus beta I am taking. Beta is given as 50, so this is 51. Emitter resistance is 1 kilo ohm plus VBE, the base emitter voltage, is 0.7. So by solving this, you will get the base current value as 40 microamperes. So now the collector current can be easily given from the base current, which is nothing but beta into IB. So beta value is 50, the base current is 40 microamperes, which can result in 2 milliamps. So now the collector current and base current are known. We have to find out the collector voltage at this point, PC or B out, both are same. So the output voltage is nothing but VCC minus IC into RC, right? So output voltage is equals to VCC is 20 volts. The collector current is given as 2 milliamps. The collector resistance is 2 kilo ohms. So the output voltage is nothing but 16 volts. So the base current is 40 microamps. The output voltage is 16 volts. Answer is option B. We'll see in the next question. For the NPN transistor connected in the circuit, VBE, the base emitter voltage is 0.7 volts. Given that a reverse saturation current of the junction at room temperature is 10 to the power of minus 30. The emitter current is. So it's asking us to find out emitter current. So assume this particular thing is a diode because the connector and base are terminated, short circuit. So this acts like a diode. So the emitter current can be written as, with the diode equation, the emitter current adopts the diode current equation, e to the power of Vd divided by eta Vt minus 1. So now the emitter current can be given as IS is nothing but 10 to the power of minus 13, e to the power of the forward voltage drop across the diode, that is VBE, is given as 0.7 volts divided by eta is assumed to be 1 here because not specifically mentioned, multiplied by this Vt is 26 millivolts. So if you solve this, the emitter current will come as 49 milliamps. Answer is option C. Sri Raghava Academy online coaching center for the regular and backlog students dedicated to diploma and engineering courses. Semester wise and subject wise coaching is available. Contact the number 70192 46753.